Okay, we'll get started. In this section, we're going to be discussing series and parallel circuits, but series and parallel circuits, specifically the mathematical part. So how you'd really do all the calculations with them. So this section, there's not a whole lot of math and there's not a whole lot of concepts, but it is tying a lot of stuff together. So it's a very important section. So the gist of this section is the following. Ohm's law, right, V is equal to IR, can be applied to simplified circuits, or they can be applied to a series or parallel circuit, each individual resistor in that circuit. So what does that mean? So let's say you had a circuit, say you just had a series circuit. So this is what the series circuit would look like. It might make sense in certain situations to create the simplified circuit. So let's label it. This would be, let's say this is R1, R2, and this would be R total. So what this section's really saying is Ohm's law, V equals IR, can be applied to this simplified circuit, can also be applied to the original circuit, each individual resistor in this original circuit. So that's what all these formulas are really saying. So this V1, I1 is equal to R1, V2, I2 is equal to R2, V3, I3 is equal to R3, and so on. What this is saying is each resistor you have, let's say we're looking at R1, Ohm's law can be applied to each individual one. So if you wanted to figure out stuff about this resistor right here, you could write out Ohm's law for this resistor. So you'd write out Ohm's law with specifically V1 for the voltage across R1 times I1 times R1. So again, you could take Ohm's law and apply it to just this resistor. The same thing with this resistor down here, R2, if you wanted to apply Ohm's law to it as well. You do V2, the voltage across this resistor is equal to the current through it times its resistance. So again, this would keep going. If you had lots of resistors, you can apply Ohm's law to each one. Ohm's law will always be valid. So again, this would keep going if you wanted to. You'd have V4 is equal to I4 times R4. There you go. Cool. So that would be the first part, is that you can apply Ohm's law to each individual resistor. You can also apply it to the simplified circuit. So this circuit right here, right, where you have R total is equal to basically the combination of these two resistors, you can apply Ohm's law to this circuit as a whole. So you could take Ohm's law, what that would look like if you wrote it out, Ohm's law for a simplified circuit would be the total voltage. So the voltage coming out of the battery, the overall voltage supplied by the battery, is equal to the total current, so the current that comes out of the battery, times the resistance total. The combination of all the resistors basically in the circuit. So if you wanted to figure something out about this circuit, you could write out Ohm's law for this circuit, and you could look at the total voltage, right? The total voltage supplied by the battery, the total current coming out of the battery, and R total. You could relate them with Ohm's law. So again, it's a little bit of a strange concept, but it's basically saying that this law right here, Ohm's law, it always works. You can apply it to individual resistors. You can apply it to a simplified circuit. It's the same idea. It always works. So what would be helpful now would be to see an example with this. So see, here we go. So again, this is an example of a problem where you're applying Ohm's law to you're applying Ohm's law to both the simplified circuit and the individual resistors in a circuit. So before I start going through this, I know it's not easy, but just please take an attempt. Okay, so again, make sure you've attempted it first. So this is a situation, we have a 3 ohm, 2 ohm, 1 ohm resistor. that are wired in series with a 5-volt battery, and A is asking us how much current is flowing out of the battery. So it doesn't say explicitly to, but always a good idea to draw it out. So battery, 3 resistors, 1, 2, 3. So let's just call them, say this is R3, R2, R1, right? So we have 3 resistors. Let's just say R3 was the 3 ohm, R2 is the 2 ohm, and R1 is the 1 ohm. There you go. And there's a 5-volt battery. So to figure this out, how much current is flowing out of the battery, well, we'd like to apply Ohm's law to do that, but we can't really apply Ohm's law to multiple resistors at once. So what would be helpful is if we created the simplified circuit. So again, the simplified circuit for series or parallel is always going to look the same. It's just a circuit with one resistor and the battery. So this would be R total. So what we have to do is we're going to apply Ohm's law here to figure out the current flowing out of the battery right here is going to be I total. V total is what is supplied by the battery, the voltage supplied by the battery, and R total is a combination of the resistors. So again, remember Ohm's law if we apply it to the simplified circuit. I to V total is equal to I total times R total. We actually know what the total voltage is. That's just the voltage that the battery supplies. We know the resistance total, or we can calculate it. So that's how we can get the total current. So we know what the V total is. That's just going to be 5 volts. But let's get R total. We're going to have to do a little math. So remember that this is a series circuit. So we're just going to add up the resistors. 3 plus 2 plus 1 equals 6 ohms. So now we can calculate. We know 5 volts total voltage. We're looking for I total, the amount of current flowing out of the battery, and we know that resistance is 6 ohms. So we're going to get a total current of 0.833 repeating amps. So that's how much current is flowing out of the battery. That's the total current supplied by the battery. And because this is a series, that's actually the current flowing through each resistor. So to do that, we had to apply Ohm's law to the simplified circuit. So that is A. That's the idea. B, what's the voltage across the 3 ohm resistor? So in order to do that, what we're going to have to do is we want the voltage across this resistor right here, R3. So what we have to do is we can apply Ohm's law, but instead of applying it to the simplified circuit, we're going to apply it to one specific resistor. So we're going to use Ohm's law and we're going to apply it just to R3. So again, it's Ohm's law. We're just going to write the numbers to just indicate what resistor we're looking at. So V3 is equal to I3 times R3. So we know what the voltage is. It's 5 volts, right? We know what the current is because we know the current is the same through everything because it's a series. Oh, sorry. My mistake. We're actually looking for the voltage, but we do know the current. It's the current flowing out of the battery. It's the same for all the resistors. We know the resistance. It's given as 3 ohms. So we just have to calculate V3 from there. Redraw that. And what that's going to give us is the current times the resistance. We get 2.5 V for volts. So that's how we get the voltage across the 3 ohm resistor by applying Ohm's law to this resistor right here. So C, what's the voltage across the 1 ohm resistor? This is the exact same thing except with the R1 instead. So we're going to apply Ohm's law to just this one resistor. V1 is equal to I1 times R1. We're looking for the voltage, but we do know the current is the same everywhere. The resistance is the same, or not the resistance is the same, but we know that it's 1. So we're going to do it out. It's going to be 8.33 repeating volts. So that is the problem. That's the voltage across the 1 ohm resistor. So I know there's a lot going on here, but just remember the only thing really new in the unit is it's Ohm's law, right? Ohm's law. It's just basically telling you something you might have kind of thought about before, is that you can apply Ohm's law. If you have a circuit, you can apply Ohm's law to individual resistors in that circuit. Well, that's where you get the, the V3 is equal to I3, R3, V2 is equal to, right, that. Or you can apply Ohm's law to a simplified circuit, and that's where you're going to get this equation with the V total is equal to I total times R total. So that's the idea in this section. It looks like a lot, but it's really just saying Ohm's law, it's always going to be valid. You just have to be careful about what you plug into it. Okay, that's it for now.